Welcome back. It's been a long time. So, MOSFET Lab 2A. We want sensor. Well, first off, information 520, 170, NMOS, LED information, light sensor information, uncovered 4K, covered 30K, resistance, motor information. I did some self testing with this guy. And joked because kind of like acceleration of deceleration, like a jerk, because it needs as much, like coke crank or something. Aiming for 5 volts, maybe around 0.12 amps for the motor. So here's the idea: 6 volts. Sensor right here. It's uncovered, so this guy would be off. This motor would be off. So this would be an open. Well, yeah, basically an open across over here. This guy will have a positive at the gate, and since that will be a positive at the gate, or greater than the threshold of the transistor, it'll open the floodgates. Yeah, drain to source. Drain to source. Since these are NMOSs. So this is my Q1, Q2. Turn it off in case I touch stuff. Here's my motor. 6 volts. This is my Q1, Q2. So OD from D to S, the gate's center pin. And for this guy, the enhanced version, the gate is the top pin right there, and then middle is drain, and then the third is the source that's drawn here. So figure it out. Well, default, because I don't want my motor to be running off for now. So uncovered sensor right there, and Q1 will be off and Q2 will be on. I'm repeating myself. Q1 off, less than 3.6 volts. Q2 on, it'll take the full about 6 volts almost at the gate, and then 6 minus 1.8. I'm aiming for about 10 milliamps across the LED, and then that got me 420 ohms. So I'm picking 470 because I don't want to burn LEDs. Unless more is better. Current 3 LED. Since I'm picking 470 ohms, that'll give me about 9 milliamps LD on. And oh gosh, I either pick looking through the phone or through my own eyes. Never both. So measuring the current through this LED give me hopefully close to 9 milliamps. Technical difficulties, but it'll give me a second. There we go. Because it's just Yes, nothing soldered. Alright, so everything's on. I don't know why it's probably touched it. It should be about 6 volts. And that's good enough, whatever. So it's drawing about 0.03 total amps. 0.03 amps. But through this guy, the resistor of the Q2 drain source, it's about 8.5 milliamps. Yeah, cool. Let's see how it's working. It's not a button. So that's like micro, about 3 microamps. Leakage is going about 0.14. Let's see how much through the voltage on the VGS of the motor side, Q1 voltage. Alright, so voltage across the VGS motor, VGS, essentially across the sensor, across this guy like so, and it's reading 3.45ish, 3.45 volts. The bodies are dead. 3.45 volts across VGS, which is below the cutoff. So Q1 is off, and since Q1 is off, the motor is off. Now raising the resistance. About VGS 4.5 volts. I just reduce the shadow a bit. 4.2 volts, 4.9 volts. Still pulling the same amount of current because I made it that way. Looks like wasting currents. So yeah. I used, there's a bad part, I forgot. So the ratio, voltage division, this is the left side, that's the resistor, Q1, the sensor, like resistance sensor thing. Off with no leakage, less than the threshold of the 520 MOS RF, 3.6 volts. So I'm picking like voltage drop of 2.5. That's good. Up to me. Voltage drop across that resistor. So since that resistor will have that much voltage drop, 2.5 or 6, and distribute that. The minimum of the 5K ohms is because this guy's about 5K ohms. But this kind of like, and then it goes, it shoots up to like 3,000 or something like that. So I did that, whatever, about 3.6K ohms. So I picked 3.3K and 330 ohms. Orange, red, orange, brown. Phone's covering very sensitive sensor now, because I mean it's sensitive. It's weak ass slow motor, but it's cheap. Now it's disconnected. Thank you for watching 10 minutes video, and remember to like, subscribe, and hopefully I'll be alright. Bye.